epic. So currently 6 o'clock. I have some people trickling in. But now we're going to be starting chapter 6 today, G5, and it's going to be about adding and subtracting fractions. So it's pretty easy, right? Let's talk fractions first before we get started with everything. So let's say, let's refresh what a fraction is. So let's say I have 1 pan of brownies and I cut it into 3 equal parts. So for instance, I have a tray of brownies, see this big nice tray, and I cut it into 3 pieces because I always want to eat 3 pieces of brownies. So 1, 2, 3 pieces. So I take 2 of them because I'm really hungry. I take 2 brownies and I eat them. So I'm left with 1/3 of my whole brownie. So because there's 1 piece out of 3. So 1/3 pieces. I think yesterday you got in G4. You already know this because I already told you this, but this is for the G5 people. Let's pretend that I ate 2 of them. Now I'm left with 1/3 because it's 1 out of the 3 pieces left. So here's something else. What if I split the tray in half, like longwise, like this? What if I did this? Hold on. Wait for it to load. Yeah, there you go. Now count the pieces. I have 1, 2, 3, 4, 5, 6 pieces of brownies, right? And I have 2 pieces of the old brownie, which used to be 1 piece. So I have 2 out of 6 total pieces. But hold on a minute. I didn't change anything. I didn't take anything out. I didn't put anything in. So that means 1/3, which we said before, which was the regular thing, 1/3, which is 1 brownie out of 3 pieces, is equal to 2/6, 2 brownies out of 6 pieces. So why is this the case? Why is 1/3 equal to 2/6? Well, I'll show you. So 1/3 equals 1/3 times 1, right? Pretty easy stuff. Any number times 1, we learned this. Any number times 1 equals itself. So 1/3 times 1 equals 1/3. Well, 1/3 times 1 is equal to 1/3 times 2 over 2. Well, 2 divided by 2 is 1, right? So I could do 2 over 2. So 1/3 times 2 over 2 is equal to 1/3 times 1, which is equal to 1/3. So nothing's changed. I did not change 1/3. 1/3 times 2 over 2 is just 1/3. And then I multiply the top and the bottom. Hopefully you know how to do multiplication of fractions. So 1/3 times 2 over 2 is equal to 1 times 2 over 3 times 2, which is 2 over 6. So that just proves that 1/3 is indeed 2 over 6. We have to multiply the top and the bottom by the same number. Otherwise, it won't equal to 1, which means it won't work. So let's look at some fractional vocab, which means like what words do you have to know? So these following words are pretty important. So the numerator is the number on top. So let's say 1/3. The numerator is 1 because the number on top of the fraction is 1. Let's say 50 over 100. 50 over 100. 50 over 100. The numerator is 50, right? Because it's 50 over 100. Numerator is the number on top. Denominator, the number on the bottom. So let's say 1/2. If I have 1/2, the denominator is 2. If I have 13 over 69, the number on the bottom is 69. And of course, this word denominator is a very important word. So hopefully you will know this word. So a proper fraction. The numerator is less than the denominator, meaning the top number is less than the bottom number. For instance, look at all these numbers: 4 over 5, 1 over 2, 3 over 4, 2 over 100, 1 over 4,982. Just means the top number is less than the bottom number. Improper fraction. The top number is greater than the bottom number. So we like to write fractions like proper fractions. We like writing it the small number on top, then the bigger number on the bottom. If you write it incorrectly, it's called an improper fraction, where the numerator is bigger than the denominator. For instance, 5 over 4, 100 over 2, 9 over 8. All these numbers, the top number is more than the bottom number. And one more term, a mixed number is a whole number plus a proper fraction. If you want to rewrite an improper fraction, you write it as a mixed number. So 1 and 1/2, 3 and 3/4, 8 and 5/6. It's a whole number like 1, 3, or 8, plus a proper fraction, meaning the top number is less than the bottom number. So you can rewrite improper fractions like 5 over 4, you can rewrite it as 1 and 1/4. You can always write an improper fraction as a mixed number and a mixed number as an improper fraction. So I think most of you guys already know this, or you should know this, but this is just a refresh. So when I say I want to add two numbers with like denominators, that means the bottom has to be the same. So if you're my G4 class, you remember that I said when you're adding two fractions, the bottom has to be the same. If the bottom is not the same, then we cannot add them. So the bottom, the denominator has to be the same, like denominators. For example, 1/4 plus 5/4 equals 6/4. The denominators of the two fractions are the same, so we're going to say they have like denominators. So what happens if we, so the like denominators are really easy. You just add the top numbers, you add them, and you keep the same bottom number. What about unlike denominators? So let's say 1/4 plus 1/2. Well, we can't add them because the bottoms are different. We just learned that if you add the bottoms that are different, you can't do that. If you say 2/6, that's incorrect. If you for the first one, if you say 6/8, you're also wrong. But here's how you can do this. We can only add numbers with the same denominator. So is the answer 3/6 or 3/2 or something like that? Well, it's actually none of those answers, and we'll see why. So we want to solve this problem, 1/4 plus 1/2. Okay, I know some of you already know how to do this, but let's go through this together. So how can I make 1/2 or 1/4 have the same denominator? Well, what did we just learn? We just learned how to make equivalent fractions. We can change 1/2, but into a different fraction. It will still be equal to 1/2, but it could have a bottom of 4. For instance, let's take, hold on, 1/2, right? 1/2, I have a feeling about this, equals 1/2 times 1. 1/2 is equal to 1/2 times 2/2, which equals 2/4. So 1/2 equals to 2/4, and now they have the same denominator. So 1/2 equals 1/4, right? So now we can solve the problem because they have the same bottom number. So we just add. So 1/4 plus 2/4 equals to 3/4. So hopefully that makes sense. Just remember, the most important part is they have to have the same denominator. And the only way to make a fraction with two fractions with the same denominator is if you have equivalent fractions. Okay, so what about subtraction? We just learned addition. So what about subtraction? Well, let's see. What happens with subtraction? Same exact thing. Well, not the same exact thing, but it's going to be very similar. So let us try. So what about 1/2 minus 1/4? Well, 1/2 equals to 2/4, right? And 2/4 minus 1/4 equals 1/4. So what about two different numbers? For example, 1/2 plus 1/5. Well, if you think really hard, you cannot multiply 2 times a number to get 5, right? And you can't multiply 5 times a number to get 2. So you have to do something different. So what can we do? We have to first, before we do that, learn what a least common multiple is. So a lot of definitions today. Fractions are indeed lots of definitions, but hopefully they're not too hard. So let's try to do the least common multiple. So let's list the multiples of 2 first. For instance, 2, 4, 6, 8, 10, 12, 14, 16, and so on. So those are all the multiples of 2. How about 5? 5, 10, 15, 20, 25, 30, 35, 40, 45, all the way to infinity. But we can see that they share 10 as a multiple. They also share 20 as a multiple. They also share 30 as a multiple. They share many multiples. But from this, we want to find the least common multiple. So what is the least of them? Well, it's 10. So the least common multiple is 10. So now we can convert. We can use this very, very sneaky fact and convert. So if both 2 and 5 have a least common multiple of 10, So we can convert 1/2 to 5/10 and 1/5 to 2/10 until they both have 10 as the bottom number, which is a very, very sneaky fact. Now, they have both 10. And now we can convert and add. So 5/10 plus 2/10 equals to 7/10. Now that's super easy. Now that you know how to do it, we can do this for 2, 3, or even 4 numbers. So I'll give you guys some time to practice these. Make sure to get the same bottom. For instance, the first one, you can list out the multiples of 8. 8, 16, 24. How about 3? 3, 6, 9, 12, 15, 18, 21, 24. They share the common denominator of 24. So just try to solve this. I'll give you guys maybe like 4 or 5 minutes, and then we'll go over them. Okie dokie, so a couple people have indeed finished. So let's try to go over them. So the first one, lots of people got this one, which was 29 over 24. Very good. The common denominator was 24. Second one is 1/6. Third one is 1/12. This one's a bit tricky because you could have said 2 over 24, but you could have simplified it to 1 over 12. Or you could have listed out their multiples, which is 4, 8, 12, and 6 and 12, and saw that 12 was the least one, not 24. And the last one is a little bit tricky because you have to list out all the multiples of 3, all the multiples of 4, and all the multiples of 5 until you get 11 over 60, which is a lot, but it is indeed 60. There's a trick when you get into higher levels of math that you can calculate this a lot easier. But for now, we're going to move on. So mixed number addition. So this is where you can make a lot of time optimization, which basically means you can get a lot faster at math. For instance, when you add 1/4 plus 1/2 is proper fraction addition, right? Because they're both proper fractions. What about mixed number addition? We just add two mixed numbers. So how do we do that? 1/2, 1 and 1/2 plus 5 and 2/5. So the steps for doing this: mixed number to an improper fraction, find the common denominator, add them, and if you're wanting an extra credit or a cookie, I know some of you have already gotten cookies, but if you have not got a cookie yet, you can convert it back to a mixed number and you can get a cookie. For instance, 1 and 1/2 plus 2, 5 and 2/5. So we convert 1 and 1/2 to a improper fraction because mixed numbers can be converted into improper fractions. 1 and 1/2 can be converted to 3 over 2 because 1 is equal to 2 over 2. 5 and 2/5 is equal to 25 over 5, which is 5, plus 2/5 is 27 over 5. The least common multiple of 2 and 5 is 10, so we have to make the bottoms 10. So 3 halves is 15 over 10. 27 over 5 is 2 over 2, is 54 over 10. And the final answer is 69 over 10, or 6 and 9/10. So it's basically very easy. You just have to convert, and then you can get your answer. So for those that are math competition oriented, here's a quick trick. So you only have to convert the fraction, the proper fractions. So 1/8 you convert to 3 over 24, and 1/3 you convert to 8 over 24, because the least common multiple of 8 and 3 is 24. So you convert those. You get 4 and 3 over 24 plus 2 and 8 over 24, which is 4 plus 2 is 6, 3 plus 8 is 11 over 24. So that's how you do it faster. You don't even have to convert to an improper fraction. You can keep it in mixed number form, and you can finish. Okay, so how about another example? Convert 1/3 to 4 over 12. 3/4 to 9 over 12, 2 and 4/12 plus 1 and 9/12. You get 3 and 13/12. But 3 and 13 over 12 is equal to an improper fraction. So you just convert 13 over 12 to 1 and 1/12 and add. So 13 and 13 over 12 is equal to 4 and 1/12. So if you're looking for speed and stuff like that, just try this method and you'll be good. So how about subtraction? So it's going to basically have the same steps as addition. So if you remember what we just did for addition, you remember this. We can take 3 and 1/2 minus 1 and 1/5 as an example. So we're going to use the tricks that we just learned, right? So first we do mixed number to an improper fraction, find the common denominator, subtract, and if you want some extra marbles and extra cookie, convert the mixed number back to an improper fraction back to a mixed number. For example, like I said, 3 and 1/2 minus 1 and 1/5 is 7 over 2 minus 6 over 5, right? Because 3 and 1/2 is 7 over 2. 1 and 1/5 is 6 over 5. So we can because they have the least common multiple of 10. So now we put 35 over 10 minus 12 over 10 equals 23 over 10, right? And 23 over 10 finally is equal to 2 and 3 over 10. Pretty easy stuff. Well, pretty difficult stuff, but it's just the method. But it just takes a long time. It's honestly really easy, but it just takes a long time. So how about if you're in competition and you're like, oh, how do I go faster? Well, we only need to convert the fraction part. So 5/6 into 10 over 12, 1/2 into 6 over 12. Because they have, or you can convert it into 6. You don't have to convert to 12 because the least common multiple is 6, but you can convert it into 12 if you like. So 6 and 10 twelfths minus 1 and 6 twelfths equals to 5 and 4 twelfths, or 5 and 1/3. The reason we didn't do it to 6, we didn't do it to 6 is because we wanted to show you what happens if you have 4 twelfths, but you can simplify it. So you simplify it to 1/3 because 4 twelfths is equal to 1/3 as an equivalent fraction. So this, you could convert to 6 because the least common multiple is 6, or you can just convert at the end. All right. So how about you do these questions? I'll give you like 7 minutes. These are really long questions. There are 2 word problems and 1 mildly difficult question. So how about you try this? I'll give you guys 7 minutes until 6:30. So go ahead and try it. All right, guys. So I think a couple of you have already finished, which is pretty nice. So let us see. So first question, 19 over 24. Second question, 6 and 7/10. And last question is 2/3. So congratulations to people that got it right. If you didn't, then better like next time practice. This is all about practice, but now that was a lot of practice. So I know it's a lot of brain workout. So I'll give you guys 5 minutes to take a little break, and then we'll come back and learn some more. So I'll give you guys until 6:35, and then we'll come back. So see you guys until then. All right, so I believe it has been indeed 5 minutes, around 5 minutes. So we're going to continue with chapter 7, which is multiplying fractions, which is a lot easier. I promise you. I promise you guys, a lot easier than adding fraction and subtracting. So how do we do this? So we don't need to worry about denominators, numerators. We don't need to worry about equivalent fractions. Multiplication is straight and easy. When you multiply two fractions, multiply the top numbers, multiply the bottom numbers. If you don't believe me, let's do an example. So if I have 20 stamps, because I'm a boring person, if I am very boring, I like stamps a lot. Some virus from China, I don't know what it's called. I have no idea what it is. But 4/5 of my stamps were canceled and only 1/5 delivered. That's pretty sad, right? How many stamps were canceled? So basically the question becomes 20 times 4 over 5. So 20 times 4 over 5. 20 over 20 is equal to 20 divided by 1, right? So 20 over 1 times 4 over 5. 20 times 4 over 5 is 20 over 5 times 4. Because we just multiplied 20 times 4 and 1 times 5. So 20 times 4 over 5 equals to, and remember you can swap them, 20 over 5 times 4. And 20 divided by 5 is 4. So 4 times 4 is 16. Or you can multiply 80 divided by 5, which is also 16. But I think 4 times 4 is easier than 80 divided by 5. So what if we wanted to bash it out? So what if I said 4/5 plus 4/5 plus 4/5 plus 4/5 20 times? Hold on, let me change the chat for a sec. All right. So what if I did 4/5 plus 4/5 plus 4/5 plus 4/5 20 times? Then it'll be 80 over 5, and 80 divided by 5 is 16. But no one wants to do that, so we want to always make sure if we can divide the top and the bottom nicely, we can do that. So for example, if you hold on, let me go back. So if we do 20 divided by 5 first and then times 4, you'll get easier than 80 divided by 5. So we can do that. So after buying 20 stamps, 4 of them did not ship. So I only have 4 stamps now. Pretty sad, but that's okay because I now know how to multiply a whole number times a fraction. But what about two fractions? What if I multiply a fraction times a fraction? So I have 2/3 friends, right? Don't worry about it. Don't worry about it. Last over the summer, I had an argument with my G5 class on what is 2/3 of a friend, but don't worry. It's just a question. So if I have 2/3 of a friend and each friend needs 3/4 ounces of water daily, how much water do I need to use every day? So ignore the fact that I have 2/3 friends. We're going to focus on the problem and not the logic, because that's in that competition. Oftentimes you have to ignore the logic and you have to do the problem. So the problem becomes 2/3 times 3/4. So how do you do that? Well, simple. I just told you guys how to do it. 2/3 times 3/4 is 2 times 3 over 3 times 4, which is 6 over 12. Or I can rearrange it until it becomes 2 times 3 over 3. And 3 over 3 is just 1, so it becomes 2 over 4, which is equal to 1/2. You can also do 6 over 12 is equal to 1/2, but I feel like this is easier. So 1/2 is our answer. So if I have this much friends and I give them this much water every day, I only need to use 1/2 ounces of water every day. So given that information, can you guys solve this problem? So I'll give you guys like 5 minutes to solve these problems and then we'll go over it. Okay, so should have been enough time to solve these problems. So let's go over them. So the first question is 2 and 1/2, I believe. Yeah, it's 2 and 1/2. Because if you multiply it out, it becomes 5/2, which is 2 and 1/2. Second question is just 3, because 9 divided by 3 is just 3. Third one is 5/12. It's just 5 divided by 12. You can't simplify it. Nothing special there. Fourth one is 34/4, aka 8 and 1/4. And the last one is 1/5. You can just cancel out the 3 and the 1/3, and you can get 1/5. So thinking time. So multiplication. So this is how to explain how to do fractions. So if multiplication is just adding a bunch of times, right? 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. So if I multiply 1 by a number, the bigger the number, the bigger the quotient, or the bigger the answer. Therefore, 1 times 1 equals 1. 1 times 1/2 equals 1/2. 1 times 1/4 equals 1/4. So by multiplying by smaller and smaller numbers, I'll get smaller and smaller quotients. Just a little reminder. So why do we work with fractions, or why do we work with decimals? Because the world does not use whole number only. Why does a ruler use 1/2 inch, 1/3 inch, and so on? Because precision. And basically, the world is imperfect. If the world is perfect, then we'd be having flying cars and stuff. But we don't use whole numbers, and we don't use whole numbers only. So, for instance, let's have a fake problem. Let's say I need 2.5 meters by 3.5 meters of tile for my new freezer. So the Home Depot I go to only has 1 meter by 1 meter, 1/2 meter by 1/2 meter, and 1/4 meter by 1/4 meters tiles. So first, I have to find what is the total area of my fridge. Which tile type should I get, the 1 meter, the 2 meter, or the 4 meter? Should I get without leftover? And which style should I use? So let's say the problem first, I want to find the area, which is 2 and 1/2 times 3 and 1/2, which is converted, which is 5/2 times 7/2, which is 35/4, which is 8 3/4. So that's my area, right? So my fridge has a total area of 8 3/4 meters squared. So which tile should I use? So lots of kids will say, oh, we use the 1/4 tile because my area is 1/4. But you have to remember, 1/4 times 1/4 is 1/16. And 1 times 1 is 1 meter squared. But 1/2 times 1/2 is 1/4 meter squared, which is exactly what we're looking for. We can use the 1/4 meter tiles to get 8 3/4. So can you use your brain and try to solve these problems? So I'll give you guys maybe like 7 minutes to try to solve these. So the questions are basically asking, some of them ask which is greater, which is less than. Some of them ask for the answer, and some of them, the last one asks for the length and the width. So how about you guys try that, and then we'll go over it. chapter now. All right, so I think that is enough time. I guess we'll go over these and then we'll be done for today. So first question, less than. Second question, 3/10 square meters. Last question, third question I meant, 8 and 17 over 24. Fourth question, greater than, and the length and the width is 3 halves and 1/12. So congrats if you got some of them right. But that's it for today. I'll see you tomorrow, and I'll send you the homework and the slides later. And have a good day. So see you tomorrow. If you don't have any questions, you can go ahead and leave.